So we're back with another example Android app. What we'll be doing here is building a really simple app that's going to just take in a number. Say, for example, you can see the mockup I've entered 10, and then it'll just spit out the numbers from 1 to 10, 1 to the number that I entered. So that's what we're going to build. Along the way, we'll learn how to use StringBuilder and some of the performance benefits with that. So that's it. Let's get started. So I'm going to create a new Android project. I'm going to use the empty activity. I'm going to call this my counting sequence app. And I'm going to put that under, okay, counting sequence. It's already under the correct repository with the correct path, so counting sequence there. I'm going to go ahead and hit finish, and we'll come back when the project is created. Alright, so I've got my mockup pulled up on the right side, and I've got the designer pulled up on my left. I'm going to go ahead and delete the hello world, and just as usual, I'm going to make two changes up here. I'm going to make sure that the system UI is on so I can see that, and I'm going to set my default margin to 8. Alright, now what I want to do is start adding in my components. So first in, I need an input box, and so this is going to be just a number because I just want an integer. So I'm going to drop that in. I am going to drop a text view where I'm going to show the output, and I also need a button, and that concludes all the elements I'm going to add for this example. All right, so just as previous, I'm going to go through and I'm going to start adding these IDs. So this is going to be number input. This is going to be my sequence output. So I'm going to write the sequence there, and this is going to be my go button. Alright, so let's start putting some of the text in. So in terms of text, I want for the number input, I don't actually want any text in there to start with. So I'm going to make sure that both of those things are clear, which they do appear to be. Next, for the button, we want to make sure that that has the text go. So I'm going to put that there. As far as the results go, I don't want any text to be there initially, so I'm going to remove it from here. Maybe I might put the text ready just as a placeholder. And in terms of what I want to preview, I'm going to go ahead and preview that sequence that I have in my mockup. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that will give me a look at it from the designer perspective. Next up, I'm going to start adding some constraints. So I'm going to constrain this up here, constrain that to the right, constrain this to the top, to the left, and to the right. Now to make sure that fills the whole space, I'm going to set this to match constraint. And then finally for the bottom, up there, here, and to the right. I will not constrain the bottom because later I'm going to put this into a scroll view, and that would cause an issue if I did. So I'm going to leave the height as wrap content, but I'm going to change the width to match constraint. As usual, that's gotten rid of my margins, so I need to add those back in. Okay, so that's a good start. Let me go back over to the design view so we can see a better preview of what it's looking like so far. One thing I might want to play around with here is the font sizes. I kind of already did that with the previous example, so I'm going to do the same thing here. I'm going to push this up to 20 SP to make that input a little bit bigger, and I'm actually going to do the same thing with the output, so that'll be 20 SP as well. All right, so I think that's most of what we need to do. If we go and look at the split view, we're definitely going to see that there's still some issues. So it's complaining about autofill hints. For this case, I don't want autofill on, so I'm going to say set import for autofill no. So that's going to add this setting down here. Next up, as far as the button goes, there's some text here we need to extract, and then I'm going to extract that as sequence output placeholder. Okay, and for the button, I'm going to extract that as well, and that's going to be my go button. Okay, I think that's tackled the things I need. Toggle visibility issues panel. No speakable text present. Okay. So there's a missing label. So upon further investigation, I've discovered that it looks like the Android docs actually want us to set a hint here rather than a content description. So that's what I'm going to do instead. So I'm going to say Android hint, and we are going to set that to enter number, ... and then I'm going to do alt enter, extract resource, and this is going to be the number input hint. Okay, so I'm going to go ahead and add that. So upon further investigation, I've discovered that it looks like the Android docs actually want us to set a hint here rather than a content description. So that's what I'm going to do instead. So I'm going to say Android hint, and we are going to set that to enter number, ... and then I'm going to do alt enter, extract resource, and this is going to be the number input hint. Okay, so I'm going to go ahead and add that. That's extracted, and that's downgraded those from a what was an error, what was a red error, down to that's taking care of this, and now there is a yellow still that's complaining about the contrast. That would be something that we need to go back and fix with theming, so I'm going to leave it alone for now. All right, so that's good for the layout. Next up, we'll work with the code. So now over in the Java code side of things, what I need to do first is add some member variables to store references to the different components on screen that I need to use. So I'm going to start with the input box, which is in edit text. So private edit text, and then this was my number input, private text view for my output, which was my sequence output, and I need my button, private button, that was my go button. Alright, so I have those things from there. I'm going to hit alt enter, add constructor, nope, I want to go here. There we go, good. So I've brought those things in. I need to grab them, fetch them from the layout, so I'm going to add a section to find the views. So first up, number input is equal to find view by ID, r.id, dot number input. The sequence output is find view by ID, r.id, dot sequence output. And finally, for the button, go button is find view by ID, r.id, dot go button. There we go. Okay, so I brought those in, and now I can start hooking up the code to actually handle and work with those. So you'll remember that I need to add some listeners. So register listeners, And first up, I need to register a listener for the button. So go button dot set on click listener. This takes a view. This needs to output. This needs to then run or execute my method that I'm about to create. So maybe I'm going to do generate sequence as the name of this method. So we're going to call it here. I'm going to define it down here. So private void generate sequence. All right. So when you click that button, we're going to call generate sequence. Also, while I'm at it, I want to set an editor action listener like we did in the previous example. So for the number input, I want to say set on editor action listener. And you'll remember that needs to take a text view that needs to take an action ID and a key event. Okay. So you'll remember that this listener is going to be triggered when the user presses that go button or the done key on the soft keyboard. So I want to call generate sequence here for that same reason. Okay, so generate sequence, and then remember I need to return false to say that I don't want to prevent the default behavior. Okay, so that's a start. Next up, we can start implementing this generate sequence function. So in terms of this, I want to first maybe grab the input that we've got. So the input should be coming in as an integer. And so that integer I'm going to call n. User is going to enter n, and we're going to pull that from integer.parseInt. So parse whatever string the user entered. And I need to grab that string. So here we want to say number input dot get text dot toString, and I need to so I'm going to take care of that. Now I have n. If I wanted to go and log that, I could go ahead and log what we got just for testing purposes. So I might want to say, hey, let's log that main activity, and their message is n equals n. That way I can look at the log and just check that that part is working. But I'm going to keep going because I'm pretty sure it is. So the next thing I'm going to do is start to generate that sequence that we're going to show in the output. So let's say I want a string, which is going to store my sequence. We're going to start that as an empty string. You'll note that I'm starting this right now without the string builder. We'll come back and add the string builder afterwards once we've kind of seen the performance differences. So I'm going to start with this with int I. Okay, we're going to start at 1 because we're counting from 1 to whatever number they entered. So I is less than or equal to n because we do want to go up to and including n, and plus plus I. So we're going to do that. All right. So loop through from 1 to n, and for each number that we go through, I'm going to say sequence, and we're going to say plus equals the number I plus a comma and a space. So this is going to end up spitting that out that way. Once the loop is done, we can finally show the result in sequence. So there I'm going to say sequence output dot set text, and we're going to set that text to the sequence. Okay, so this is my starting point. I'm going to go ahead and try it on the emulator at this point. Alright, so my app is up and running. I'm going to try and enter 10, and let's see if we get our expected result. I can try to click the done key here. Looks like it's working. You might notice that there's an extra comma at the end. That's okay right now. I'll come back later when we deal with the StringBuilder and show you how to remove that extra comma at the end. But for now, we're going to leave that in place. One thing to note here, this does work just fine if I click this button, but you might notice when I hit go, it has the intended result. I can say maybe let's go up to 20 and hit go. It does update the count, but it doesn't dismiss the keyboard like I like it to. So I do need to make a little change there. So just like I did in the previous video, I'm going to paste in a snippet of code to hide the keyboard, as we show here. Pause the video if you need to get that bit of text. But I'm going to then use this hideKeyboard method up here. In the onClick listener, I'm going to say hideKeyboard, takes this, and I'm going to pass the go button as the relevant view. All right. So if I try that now, what I should see is type in 20, hit go, and the keyboard is dismissed like I want it to. Now, another thing I need to test is what happens if I put in, say, invalid input, right? So what happens if I just leave this field blank and hit go? You'll notice that the application crashes, right? So I don't want that to happen, right? Well, I know that the application is crashing because of this integer.parsint, and I could look at logcat and verify that that is the case. So what I need to do, if you'll remember, is I need to wrap that in a try catch. So one approach that we could take is to just wrap that one section, and that's oftentimes what I'll do in a larger form. But in this case, there's really only one input, so I'm going to go ahead and just wrap the whole function in a single try catch. So here, I'm going to say, okay, well, the only thing that could cause that is this one, and there's no point in proceeding further if there's a problem there. So I'm going to go ahead and wrap the whole function in a try catch. Here we're going to catch the number format exception, and when that occurs, I'm going to log it. So log.e. We're going to say main activity is our tag, and our message is invalid number, and we're going to spit out the exception. So we're going to log all that, and then as far as the user is concerned, we're going to say sequence output dot set text, and we're going to set it to the text invalid number, or invalid number. I'm going to also extract that while we're here. So we're going to extract that as a string resource. We're going to call that error invalid number. Okay, so that's been extracted, and now we can try testing it again. And if I leave the field blank this time, it should not crash. So we've tested this with relatively small numbers like 10 and 20, and we've seen that it works for those small numbers, but I need to see, what happens with maybe a larger number. So let me try a bigger number, say maybe 1,000. Hit go. And we're going to see it works, except that I have this problem now that my numbers are falling off the edge of the screen and I have no scroll view. So I definitely need to add a scroll view so that I can see those longer sequences. All right, so I'm going to go over to the project. I'm going to add a new layout as we've done before. So that new layout here, this is going to be my activity main scroll. Okay, I'm going to add that. I'm going to go to the split view so I can edit the code. Minimize this over here, make that wider. All right, push this down. I want this to be a scroll view instead. There it goes. I need to close the ending tag. Change the ending tag there. I'm going to add my include tag. Okay, and so I need to set the width of it to match parent, the height to wrap content as usual, and I need to set the layout to point to our other layout, which is activity main. All right, so that's good. And you can see the preview is starting to look the way I need it to. Now, I'm going to go back to my Java code, because remember that I need to set up here on line 25, set this layout to be the new activity main scroll. So that's what we're passing to set content view. All right, so I'm going to go ahead and run the program now, and we should have a scroll bar when I enter some larger numbers. So 1,000. Go. All right, and I can see the full results of that, which is great and is really helpful for seeing and testing what we need to test. So now that we've got the basics down, I want to try this with a much larger number. All right, so maybe I go up to 1,000,000. All right, let's see what happens. I go. Notice the program's actually freezing for a bit, right? It's freezing because it might seem like a really simple thing to count up to 1,000,000, but that's actually pretty expensive. It's actually taking quite a bit of time right now. And so you'll notice that the app is actually frozen. It says counting sequence isn't responding. So this is what we call an ANR, an Android not responding dialog. This occurs anytime you're holding up the UI and not letting it render or the user interact with it. These are things that we want to avoid because typically when this occurs, the users will dismiss click this close app button, dismiss your app, and goodbye. You may have just lost them. So we want to make sure that that dialog doesn't appear in the first place. But you'll see that it's still working. It has not finished. So that is a surprisingly costly operation. But why? Why? What is going on here? The main thing comes down to is it actually has to do with the amount of memory that needs to be allocated. And there's a lot of different operations in that memory allocation that make it slow. So let's use the profiler that's built in Android Studio and try to see what's going on. So first things first, you should have a profiler tab down at the bottom, and we can bring that up. If you don't have that, you'll want to go into View, Tool Windows, and open up the profiler right here. Okay, it may start pretty small like this. You'll want to go ahead and resize it tall enough so you can see what's going on. I'm going to go run the program. That's going to automatically add and attach this profiling session while the window is open. Okay, so you can see that there's a few different charts that it's rendering. So we can see CPU usage. That is when it's actually doing CPU processing calculations. Right now you can see it's basically asleep because we haven't told it to do anything. And you can see that the memory usage is pretty static at 95 megabytes for what it's just doing right now. You can also see the energy usage down here. That would be how much battery usage is being used, and you can sporadically see that it pops up because there are background things occurring. All right. So let's start entering some numbers and see what happens. So if I type in, say, 1,000 and hit go, we're going to see a really short quick spike here of CPU usage, and you might see a quick spike potentially in memory usage as well, where it changes slightly according to that. But you'll notice it's a really quick spike because going up to 1,000 doesn't take a lot of time. If I go just a step up and I say maybe 10,000, we can see that there is a bit of a longer trail, right? So it's not a quick spike like those other ones. It takes a little bit longer to do that calculation, and you can also see there's a corresponding bump over in the memory side. Now, if I jump up all the way to 1,000,000, which is where we were a second ago, and hit go, you'll see that that CPU tail, as it goes, is quite a bit longer, right? So it's continuing to work. It's continuing to crunch there. You can see that the memory usage is bouncing up and down a lot because it's needing to use a lot of memory to do this. But you also notice that it's going up and down because there's a lot of memory being allocated, but then also consequently released. But you might notice that there's a slight uptick where over time it's slightly using maybe more and more memory. You can see where it started closer to 100. It's now approaching closer to 170, bouncing around 190, and that will continue going as this process continues. Okay, so the problem and what's causing this is actually this line right here, line 50, where we're doing string concatenation. Because what happens is anytime we do this, it has to allocate a brand new string. So what we do is we say, okay, let's take the whole sequence that we have, plus the characters that we're adding. So let's say we've got 100 characters already in the sequence and we're adding another 4. I need to allocate a brand new array in memory to hold those 104 characters, copy 100 characters in, copy 4 characters in, and then throw away the 100 character string. And it keeps doing this every iteration. It's doing this a million times. And because of that allocation, that copy and allocation of that larger string is what's taking this long. Okay, so what we can do is we can introduce a string builder, and that is going to make this program run much faster because it's going to speed up and make this more efficient in terms of how it allocates and uses memory. All right, so the transition here is pretty simple. Rather than using a string here, I'm going to change this to a string builder. And rather than saying this is equal to an empty string, I'm going to say this is a new string builder. Okay, so a new string builder, if you allocate it, create it without any parameters, then it's effectively the same as an empty string. If I wanted to allocate it with some sample text in here already, so I would start it with that string here. But I want to start this empty, so I'm not going to provide any constructor arguments. So we change this over to a string builder. The next thing I need to do, because there's no plus equals with that string builder, there's no plus equals operation, I need to use the method append instead. So I'm going to say append, and so I'm going to append the number, and then rather also than using that plus, right, because I was saying I plus comma space, I'm going to append that as a separate string. So append, boop. So I'm really doing 2 appends. First to append the number, and then also to append a comma and a space. All right, so I'm going to do that. And then at the end, we actually, notice, don't need to do anything because it turns out that the setText method already takes a string builder. Now, why is that, right? Why is that we can pass a string builder in there? Well, if you look at the signature for setText, you'll notice that it takes a char sequence. It doesn't take a string, it takes a char sequence. Well, it turns out both strings and string builders are both inherited from that char sequence class. So we can just directly pass it through there. If I did for whatever reason need a string, I could call sequence, take the string builder and call toString on it. That would give me a string. But here, and this is commonly the case in Android, I really just need a char sequence, so I don't necessarily need to turn it into a string. All right, so I made those quick changes. I'm going to go ahead and run the application again, and we can see how the performance is different. So we're in a new emulator. I'm going to make sure I clean this up, so delete both of those and start the app again. So I only have one that I'm looking at. If I go for maybe waiting for that to start, okay. So maybe if I go for 1,000 and hit enter, we're going to see that that completes again very quickly. But look at the spike, right? So we can't tell much difference, right, with a very small number there. Let me try 10,000. Remember that was a larger spike. So 10,000, okay. Actually, the spike already has gotten shorter, and notice that there's no noticeable difference even in the memory usage. It stays basically on the same level at this 10,000. Okay, now I'm also going to go all the way up to 1,000,000 and go ahead and try this. And what we'll see is it's processing as it did before. So we're still watching it. It's still processing. We still get an ANR, right, because this operation is still expensive. It hasn't gotten us out of that. But we will notice here that there's a much more predictable and a much more smooth curve to this. That's because, unlike previously, we're not allocating and destroying a string every single iteration. We're not going to allocate and destroy a string every 1,000,000 iterations. Instead, what happens is the string builder has kind of this internal buffer, and it will allocate extra space to hold future characters. And when it runs out of space, rather than just adding the space it needs right then, extending the length of the buffer then, it will actually double the size of the buffer, meaning that it's less likely it will need less allocations in the future. So that's why this is being much more consistent over time in terms of how it's growing. Now you can see it's getting a little bit more erratic at this point. It's still more stable than the original version, but you can see that there's some back and forth here. I'm going to go ahead and let this run for a bit, and we'll come back when this completes. So it's been running for over 15 minutes, just stopping it, since it looked like it could continue for a while. So you can see, even with a very simple application, really here I just want to count from 1 to 1,000,000. What seems to be pretty simple can actually be, sometimes can be a pretty slow and tedious operation of just, that's a lot of numbers that it has to spit out and a lot of memory it has to use. So now we've done some analysis of what it looks like between using string concatenation with a string variable versus using a string builder to achieve that same effect with the append method. We want to look at how can I solve that problem of the trailing comma. So if you remember right, let's say enter a very short sequence, ask for 20, you'll remember that there's always this trailing comma at the end. It turns out that that is very easy to remove once we're working with the string builder. So what I can do is, once the loop completes, is I can say sequence dot and remove or set length. And what I'm going to do is I'm going to set the length of the string to the current length of it minus 2. So I'm going to say sequence dot length minus 2. So we're going to set the length to its current length minus 2. Why minus 2? Because there's a comma and a space at the end. And so I'm going to remove those two trailing characters, and that will solve our issue. That works. The observant among you might notice that there's a bit of a problem that I've introduced. Depending on what value I've entered, this actually might result in it potentially trying to set the length to a negative number. If the length of that string is 0, then I'm trying to set the length to negative 2. And so if I try maybe, hey, let's say 0, go, the entire application crashes because you can't set the length of the string builder to a negative number. It has to be a positive number. So what that means I need to do here, I need to say if the sequence's length is greater than 2, or greater than 0 rather, if it's greater than 0, then I will remove that. Because as soon as I answer the first number, that will be long enough. So I just need to check that it's not empty. So as long as the sequence length is greater than 0, go ahead and remove those last two characters. Okay, so if I enter 0 now, it doesn't crash. I can enter 1, all good. I can enter 20, all good there. Okay, so that's the simple trick in terms of removing the trailing comma, is you just have to check, hey, is the length non-zero? Is it long enough? Does it actually have a trailing comma? And there's more than one way you can check that, but that's usually the easiest way. The other thing we then do is just set the length, right? So just set the length down, removing 2 characters from the end. And that's it. So this has been a really simple example of how to count from 1 to n. And along the way, we've learned out how to use a string builder and how to use that to improve the efficiency of our applications and kind of the why of why we want to use that string builder over concatenation. And a lot of times this comes up anytime where you're doing something where you're doing that concatenation in a loop is oftentimes the place where you want to do this transformation. All right, I will see you next time.